Today we are going to be looking at two learning targets, both involving our new unit of quadratic functions. The first one is going to be the ability to understand relationships between multiple representations of quadratics, and the second one is going to be talking about identifying key features of quadratics. They fit pretty well together, so we want you to be able to see them side by side and make sense of them all as one. The first thing that we want to look at is what are the different representations of a quadratic? Well, before we can do that, we have to look at what the equation looks like. And here in the middle of our page, we can see that we have the quadratic function, or quadratic equation, y equals x squared plus 2x plus 5. Now, we see that we have a graph on the left here that we don't know much about yet, but what I can tell you is that it does connect to our beginning equation. So what we're going to do is we're going to pull up our graphing calculator, and I am going to go to y equals, and I'm going to type in our equation. So I'm going to type in x raised to the second plus 2x plus 5. Now, my equations match. Now, if I hit graph, I get a graph that actually does match ours. Now we can see here that if we go to our table, we get some points. Now, these points are all important for us because we want to figure out where our vertex is and where some matching points are. So, if we look here, one thing that you will see on the graphing calculator is that this point of negative 2, 5 matches with this point of 0, 5. So we have this point negative 2, 5 right there on our graph, and then we have the point 0, 5 on our graph as well. Well, the point that's halfway in between those, which in our case is negative 1, 4, is this point that we see on our graph, and it has a special name called our vertex, and we'll talk about that a little bit later. And then we can add any other points that fit, which we can add the point 1, 8 right here. And if we went out to negative 3, we have the point negative 3, 8, which would be right there. So please make sure you take a minute and get your graph filled out to match your equation. And then the other thing I would like you to do is we are going to add these points into our table. So we have the point negative 3, 8. We have the point negative 2, 5. We have the point negative 1, 4, which is special because it's our vertex. We have the point 0, 5. And we have the point 1, 8. We have another blank spot so we can fill it in with the next point, which is 2, 13. Now, what I want you to see here is that in your table, you always have pairs that are symmetrical for your y values. So we have a 5 and a 5, an 8 and an 8. If we went back to negative 4, we would have a positive 13 to match with our 13 down below here. But either way, what I want you to see is that we have three different representations of a quadratic, and to get all of these, you just simply want to use your graphing calculator and plug in that equation, graph it, graph the points, fill in the table. We can get all three representations pretty easily through that. Now, the second thing we want to ask ourselves is what key terms do we need to know, what vocabulary do we need in order to really understand quadratics? Well, there's a couple things that we need to be able to talk about in order to really discuss quadratics well. The first and most important thing we need to be able to talk about here is this point right here, which is at the apex of our quadratic, and we call it the vertex. Okay, Now the vertex is always, always, always either at the very bottom, meaning it's a minimum, or at the very top, meaning it's a maximum. So out here I want you to add that this is either a minimum or a maximum. Okay? Because that minimum and maximum plays a big role in making sure we understand what happens. Both of these play into concavity, which we will talk about here in just a minute. Now, the second key term that you're going to be able to need to know is these 2 points here that, again, are symmetrical about our vertex. Now, both of these are where the graph crosses the x-axis. So these are our x-intercepts. Okay, so you can label those as your x-intercepts. We also have a point down here where the graph crosses the y-axis, so we're going to call that our y-intercept. So we have our x-intercepts, our y-intercept, we have our vertex, and we have one other key element here. The other key element that we have is, if we can get a highlighter so I can show you this, we have this line right here, which that line is what we call our line of symmetry. So here in this box, we can label this our line of symmetry. It means that our graph is symmetrical about that particular line. Now, the one thing that I was going to tell you is that we have two things that we need to be able to talk about. I told you we called it concavity. So we can make a little note here that says we have concavity. Which really means one of two things. If it is what we call concave up, that means the graph opens up, and it would mean it has a minimum value. If the graph is concave down, that means the graph opens down, and has a maximum value. So we have those two options. We either have concave up or concave down. In this case, with the graph that you see in front of you that you just labeled, our graph, this is a low minimum value. So it's a minimum. The graph does open up, and that means it is concave up. If it were flipped and you had a maximum, it would mean that it opens down and the U would be going the other direction, and you would have a maximum value. So those are two things for you to add that you'll want to be able to talk about when discussing quadratics. The last thing we want to talk about here is what are the different forms of a quadratic and what key information can they provide us with. Now, it's important that we always make sure we get our forms written in with the correct notation and correct superscripts, subscripts, exponents, all of that stuff, because it's all very important. Now, you've been given on your paper the general equation of each of the forms. We want to go ahead and add an example equation and talk about what key information we can pull from that. So, here, we're going to fill in some equations. So we're going to start by filling in our standard form equation, which in our case is going to be y equals x squared plus 2x minus 15. What I will tell you is that all of these forms of equations will all be equivalent. They're just written in different forms. So just like in linear equations where we had slope-intercept form, standard form, point-slope form, that could all be the same line, just written three different ways, the same thing applies here. These are all the same quadratic equation, just written in different forms. We're also going to write our vertex form, which, if you were to convert this, which you'll learn how to do later, is y equals x plus 1 squared minus 16. Okay? Now notice in both of these we have an a value that appears like it didn't get written, but remember that just means it's an a value of 1. We will also write our factored form of our equation, which in our case is y equals x plus 5 times x minus 3. Now, like we said, each of these have different advantages to them because they give us different pieces of information. We will start with the key pieces of information that are given to us by our standard form equation. Our standard form equation gives us the following key pieces of information. The first thing that it automatically gives us is our y-intercept. Our last number here, in this case being negative 15, is always our y-intercept. So we can write this as the point 0, negative 15 as our y-intercept here. The other thing that it tells us is because our a value of 1 is positive, if it has a positive a value, that means it's concave up. So we can say that our graph will open up, and that means that it will have a minimum, not a maximum. So we know that it will open up and have a minimum. That a value tells us that very, very easily. Now, those are the two real key pieces of information that we can get out of standard form. Out of vertex form, the key piece of information that we can get, you guessed it, is our vertex. So our vertex in this case is just like you've seen it before. Whatever's inside parentheses is always opposite of what you think. So instead of it being a positive 1, it is going to be a negative 1. So our x value is negative 1, because it's opposite of our x value in there. And then our y value is always the same as what you see, so it's negative 16. So we have our vertex of negative 1, negative 16. Now, the other piece of information that this gives us in vertex form is our axis of symmetry. Our axis of symmetry always is the equation that runs through the x-coordinate of our vertex. So it's always x equals whatever the x-coordinate of our vertex is. So in this case, it is x equals negative 1. Now, because we also have an a value written in vertex form, it's very, very easy to see that because our a value is, again, it's that positive 1, it's positive, that means it opens up and will have a minimum value. So we can say it opens up and has a minimum value. Now, if we go all the way over to factored form to figure out what information that gives us, the easiest things that we can say are that it tells us what our x-intercepts are. Now, our x-intercepts are always the opposite values of what we see here in our factored form equation. We can get these by setting each of these separately equal to 0. So we could write x plus 5 equals 0 and x minus 3 equals 0. To solve this, we would subtract 5 from both sides. So we get x equals negative 5 as one of our x-intercepts. And on this one, we would have to add 3 to both sides. And we would get the value x equals 3. So in both of these situations, we get the point negative 5, 0, And in this case, we get the point 3, 0 as our two x-intercepts in this case. Also in factored form, it's easy to see that because our leading coefficient, it doesn't have anything out there, we assume it's a 1, we know that that means it opens up and has a minimum as well. We're going to talk about how to get some of the other pieces of information from our different forms. They're just harder to find. So I'm going to have you guys make a few notes that we'll come back to and reference later. The first one of these is how to find our vertex, or how to find the x-coordinate of our vertex. Now that is going to be the equation x equals the opposite of b, so negative b, over 2a. And that comes from our a, b, and c in our standard form of our quadratic equation. So make sure that you keep that written down, and we will talk about that later on in this unit. The other piece of information is that also plays a role into our axis of symmetry, so you can add that same equation down here. X equals the opposite of b over 2a. And we will come back and use that later. The rest of this table will get filled in as we learn how to either, 1, convert between the different forms, or 2, talk about how to use our information or factor equations to come up with the different key pieces of information about quadratics.